Once you open the simulation handout, if you have on hand, you can use them to actually do the simulation, but you can also just think about what's happening. But if you have on hand a coin, six-sided die, eight-sided or 12-sided die, and four playing cards, you can try to do it on your own to do the simulations. But otherwise, just kind of think about why can't you use a coin? We already talked about a coin only has two possibilities, heads or tails, so it doesn't simulate one out of four. So a coin doesn't work, so we don't have to worry about filling out the simulation part. Can we use a six-sided die? Same thing. We can't do it because we cannot simulate a one out of four likelihood of an event. So we don't need to worry about filling out this chart. Can you use an eight-sided die or a 12-sided die? At first you might think no, because eight-sided die has eight options, but you gotta think about, can you get a 1 out of 4 probability? And yeah, we can. So in this case, you can use it. Also for a 12-sided die, we can get a 1 out of 4. So for an 8-sided die, what you can do is assign tap water to two values. So for example, the number 1 and the number 2 will be tap water on an 8-sided die, or number 1, 2, and 3 on a 12-sided die, and so on. So since we can use that one, we will fill out the simulation. So the simulation is roll of a die, success, failure, chance of success. But what does it mean in terms of our actual experiment? So one roll of the die is choosing a type of water. Success is choosing tap water. So in this case, we need to specify what is a success. So for an 8-sided die, it will be rolling a 1 or a 2. And it can be any values. You could choose it to be 7 and 8. And then everything else will be a failure. Failure, choosing bottled water. So that will be rolling anything that's not a 1 or a 2. So 3, 4, 5, 6, 7, or 8. The chance of success, 2 out of 8, which gives us 1/4 chance, 1/4 probability. And one repetition is just 27 people choosing water. So you will simulate, you will do this rolling a die 27 times. So doing this 27 times will count as one repetition. The easiest one to use will be the tool number 4, 4 playing cards. So that one, we have 4 options, so it matches the cups of water. Choose 3 black cards for bottled water and 1 red card for tap water. Let me card there. Or you can do it by suit: spades, clubs, diamonds, and hearts. So you can assign hearts as the tap water, and then everything else will be bottled water. So the flipping of a card will be choosing a type of water, and then if it's for tap water, it will be selecting the red card. If it's a black card, that will be as if you chose bottled water. Again, we're trying to randomize the experiment. We're trying to assume that things are happening at random. And so that's why this simulates the null hypothesis, that things are happening at random. So going back to the handout, once you've done the simulation, then you will do it with using the cards. So if you want to do it at home on your own, we will do it here. So do it 27 times. Success will be getting a red card. Failure will be getting a black card. And then how many red cards do you get? How many black cards do you get? And the proportion will be out of 27. We did not do this in class. I said move on to the next part, which is the computer simulation. This will be very similar to what we did in class with the friend versus foe, the baby study. And so you would open up your one proportion applet and change things to, instead of 0.5, it will be 0.25. We have 27 people, so the sample size is 27, and we're going to do 1,000 samples. And so on your one proportion applet, you want to go to modules and all applets. So once you click on all applets, open in a new window, and these are all the applets we're going to use. So you go to the one proportion inference applet, and it comes up like so. And notice that it doesn't look quite like the handout does, and that's because this I already cleared it to not be a coin. And so how you clear it to not be a coin is you just got to change this to not 1/2. So if I put 0.25, notice that now it gives me probability of success rather than probability of heads. We're going to change that to 27. In number of samples, we want 1000. So that it goes faster, unclick the animate and be sure that you have your summary stats button clicked because that gives you the mean and the standard deviation. And we also want to move this radio button to proportion of successes. So not the number, but proportion. And draw samples. So this is our simulation for 1000 samples. Notice that is pretty symmetric. So if you could draw a bell-shaped curve, it would be pretty symmetric. The mean is 0.244, so it's very close to 0.25, which is a quarter, so that makes sense. And my standard deviation is 0.084. So you should get the results very similar to this, very close to 0.25 for the mean and around 0.08 for the standard deviation. So how can you tell whether the simulation results appear to be correct? Center around a quarter. Like we said, if we're doing this at random, there's 1 out of 4 chance of getting the tap water. Where does our observed value of the statistic fall in the distribution? Our observed value is the 3 out of 27, which is 0.11. So looking at 0.11, it appears to fall on the left tail. So I don't have the graph here, but when we go back to the applet, 0.11 is somewhere around here, so it falls on the left tail of the distribution. And I want you to go through the rest. The rest is very similar to what we did with the baby study, friend or foe, and answer the questions. So what do you want to consider or more extreme than this statistic? More extreme will be anything that is the same or smaller than the observed. The observed is 3 out of 27, so more extreme will be 2 out of 27, 1 out of 27, or 0. And the strength of evidence, approximate the p-value, use several thousands of simulations. So fill in the proportion of successes box with the 0.11. So I'll show you how to do that. So it's here. So make sure that the radio button is on proportion of successes, or extreme value is the 3 out of 27, which was 0.11. And we want to make sure that we change this symbol to less than. Less than. And there's our p-value. Now I did say use several thousand, so you could draw samples again just to get 2000. So that's my p-value, 0.0680 appears to be the p-value. I may have gotten something different while I did it here, but it's very similar. P-values will vary, but you should be very close to 0.067, 0.07, somewhere around there. So if people make their water selection at random, right, they're guessing or there's no preface, then there is a 6.7% chance that 3 out of 27 people select tap water. This is important. Remember, interpreting the p-value is different than making a conclusion. Making a conclusion is based on the p-value, which again, that goes back to section 1.1, this table. So you have to compare your p-value to this table here. and I got 0.06, so it's not quite less than 0.05. So we're only here at some evidence against the null hypothesis. And so that's why you'll notice here, since our p-value is less than 0.10, we have some evidence to suggest that people are not just randomly choosing water. That means there's some evidence that people prefer bottled water, but we don't have a strong evidence. And so here I talk about the significance level of the p-value, and what if we set it at 0.05? And this one refers to the friend versus foe study. So I hope that this helps you finish this handout and get the concepts. And the group project, section 1.3, it'll be very similar to this, but you'll go through it on your own. So I wanted to just make sure that I explained some of the topics we saw. If there was any confusion, email me and let me know if there are any questions, and I'll try to answer them, or post in the Q&A forum. All right, I hope you have a good holiday weekend and that you are getting together with your group partners. And by getting together, I mean through email or using your own group discussion, or texting, or having phone calls. And if you have any questions, please don't hesitate to email me.